Let's walk through an example around dependencies. Say we had a class for a rectangle that might have a width and a height. Then we could use that rectangle and let's just output its size. So what does this do for us? Rectangle is 100 by 100. Well, that's about what we expected. Now there's a couple of things we can do here. I don't like to have to do this. Maybe these are default values, like in the previous example. And so maybe we have a public constructor that sets those for us. Then we don't need to set them there. Our rectangle is still 100 by 100. And maybe this can be turned into a function as well. And that should work. So, say now we wanted a square. Now, mathematically, a square is a kind of rectangle. It's just a special case. So we could do that. Class square extends rectangle. And maybe we created ourselves a new square as well. And output its size. Now we have two shapes. But now we also have a problem. If I want to set the size of that square or that rectangle, I can't do it the same way. Let me show why. So if I said that the rectangle's width is 200, then that works. But does it really make sense to say that the square's width is 200? What happens to the square's height? Well, we only have two variables, and 200 by 100 doesn't make a square. So things are starting to break down for us. So what if we decided to fix this by writing a function? Let's see. Maybe we can put the logic for it in a function to say resize for a width and a height. I can just move that functionality around. But I can still set the width and height independently, and the square still isn't a square. Oh, it could be a square if I was careful in my code. And maybe if in the rectangle we said if this is an instance of a square and you've asked me to set the width to something different than the height, then I could say can't do that. Which would work. Oops. But now, look what we've done. Square extends rectangle. So square depends on rectangle. But now, rectangle references square. So rectangle depends on square. We've just created a cyclical dependency. And this is bad. So let's work our way out of this with the suggestion that we'll create a common base class to remove that cyclical dependency. So say we have a shape, and the rectangle can extend shape, and the square can extend shape. So now rectangle and square both depend on shape. Now say we want to get rid of this. What we might say in shape is if we make it an abstract class, then we can have an abstract function for resize that maybe instead of a width and height, maybe we're not sure what kind of polygon we're going to get here. So why don't we just take, we'll take an array and we'll call it lengths. Now when we implement this function in rectangle, you're going to get the lengths. I'll just take that piece of code out and we can say that the width maybe is the first and the height is the second element in that array. Now shape is a concrete class, so it also has to implement the resize function. And how would we do that there? Well, maybe a square has a size and has a constructor that sets the size. And when we're asked to resize, we set the size from the first element in the array. So now these would work like this. I could say array 200, 100, and an array with just 200. And this should now work. Oh, not quite. We need a getSize function for the square. That does the right thing for a square. There we go. We have two abstract functions from our shape class that we're implementing as a rectangle and implementing as a square. And then we have code that uses all of that. Do we work? Nope. There we are. We have become nice and clean again. Rectangle only references shape. Square only references shape. Our dependencies all now point in the same direction. And we have removed the cyclical dependency.